Okay, so welcome everyone to our sixth and final Environmental Friday guest lecture. We've gone through a lot of different really cool topics and very interesting and informative speakers. Our speaker today, Dr. Motria Caudill, has been a great supporter of our Environmental Fridays and our desire to incorporate environmental science into chemistry, into our grade 10 chemistry class. And so we want to thank her for that. In fact, today is her second talk for this semester. Um, Oftentimes when people talk about climate change, they get a glazed eye like, okay, what is that? But hopefully today's lecture will tell you and show you that climate change is personal, like it affects your health, okay? It can't get more important than that. Our speaker is an environmental health scientist at the Agency for Toxic Substances and Disease Registry, which is a part of the CDC, Centers for Disease Control. She's also an adjunct associate professor at the University of Illinois at Chicago. She's also an adjunct professor here at Andrews University. Her work has taken her around the world to India, Vietnam, Ukraine, conducting research projects and training local specialists. She has a PhD and a master's MS in environmental and occupational health sciences from University of Illinois, Chicago, and with a focus on toxicology, risk assessment, and air quality management. So it's really a good pleasure again to have you here with us today. Thank you so much for accepting our invitation, not once, but twice.
Thank you, Dr. Murray. Good morning, everybody. Thanks for having me back. And the benefit of speaking more than once in a series is that I know what I talked about before, and I had the pleasure of listening to some of your other speakers. So I get to build on that a little bit. And I was happy to listen to your environmental journalist last week. I happened to, Ms. Denise Chow, I've already been following her on Twitter. So when the name popped up, I said, wait, I know who that is. Yes. So it's nice to be in that company. So happy to be back.
Thank you.
And I've been an environmental health scientist for over 25 years now, and just wanted to put in a quick disclaimer that I'm here as a scientist, as an independent person, not representing the various government agencies that I currently or previously worked for. Although I do draw a lot from government resources for this presentation. So today what I wanted to talk about is to briefly touch on a global challenge that we have made significant progress. There's a bit of inspiration here, the ozone layer. We'll talk about climate change, evidence and causes of it, and then a focus on effects on human health. And then we'll talk a little bit about solutions and the way forward to battle climate change. The ozone layer. I'll remind you that we talked about ozone when we were discussing air pollutants. Ozone is good up high, bad nearby. So just as a quick reminder, ozone, when it's at ground level, it is hazardous to our health. It's one of the regulated air pollutants. But up in the stratosphere, about 20, 30 miles above the Earth, it is a protective layer and it is good for our health. So to elaborate on that a little bit, good versus bad ozone. Up high in the stratosphere, the ozone layer, it's a protective layer. It absorbs ultraviolet radiation. It helps keep the Earth warm. Without it, so much of the radiation coming from the sun would bounce off and we would have a very cold planet. So it is important to have some amount of protection to keep that heat in our atmosphere. And it also filters out ultraviolet B radiation, which is a contributor to skin cancer. So it is good to have that stratospheric layer. Bad is the ozone at tropospheric, at ground level. And this is for a couple of reasons. It's harmful to the natural environment. It reacts with plants, resulting in harmful effects on crop production and on forest growth. So it harms our ecologic systems, and it reacts chemically with animal tissue, resulting in harm to us and to animals. It affects our respiratory system. And so we like to limit our exposure to ozone at ground level. So putting aside the ground level issue, we're not talking about air pollutants today. A little more about the ozone layer. The reason you may have heard that there's a hole in the ozone layer, and that's because that layer of ozone high in the stratosphere, it was depleted by human-made and used chemicals over the span of many years. Once we figured out in the United States and as a global people, once we realized what was happening and that it was directly related to our consumer choices and our industrial operations, we realized this is something we needed to address. So in 1978, the United States banned products that contain chlorofluorocarbons, CFCs, and they're in propelled hairsprays and deodorants. So these were the consumer products. There's also industrial uses. And once we realized that that was the main cause of depletion of the ozone layer, which we need to have, we decided to ban it in the United States, and other countries banned it. And then in 1987, the Montreal Protocol was a major international agreement to phase out ozone depleting chemicals. And this agreement was universally ratified by countries that participate in the United Nations. And so I like to bring this up as a success story. We do have quite a few success stories in the area of ground level air pollution, handling issues, an entire pollutant nationwide, or local scale issues. But this is something that we've tackled on a global basis, and we're making very good progress. The United Nations declared in 2019 that we are on track to heal the ozone hole, and there's different websites that track the progress. And so they have measurements of how big the ozone hole is and the thickness of it in certain places, the thickness of the layer. And so in 2019, you could see just from these couple photos here that we had a pretty good improvement over a couple of decades before. Dr. Murray, can I confirm that you're getting my audio okay?
Oh, yes, we are hearing
right.
you well, yes.
All right, I'm hearing little blings, and I'm not, since I maximize this screen, I'm not seeing the classroom anymore. So just me and my slides. Okay, so moving on to climate change. There is a difference, and I hope we all know the difference between climate change and weather. NASA defines climate change as a change in the average conditions, such as temperature and rainfall in a region over a long period of time. NASA scientists have observed the Earth's surface is warming, and many of the warmest years on record have happened in the past 20 years. So this is not a short-term fleeting issue. Ironically or paradoxically, the cold waves in Texas a couple weeks ago and the health and catastrophic aftermath of that's actually a feature of climate change, because the world itself is warming, but one of the byproducts of the broader phenomenon of climate change is that there's more extreme weather events. So here in the Midwest, we were perking along with an unusually warm winter. December, January, it's warm. We feel like maybe we're out of the woods. We are a little worried because it's warmer than it should be, but it's nice. And then the polar vortex hits us, and that's because of climate change. That's because events at the Arctic are breaking down. And so even though we had a deep freeze and a lot of snow, that's actually a feature of climate change. So I'm using climate change and global warming kind of interchangeably, but global warming is really a subset, and climate change is more the broader consequences, and it includes both the human-caused and the naturally occurring phenomena. So I'll use them interchangeably, just be aware they are a little different. And focusing on global warming, which is the crux of our issue, causing our planet to heat up. What causes it? Well, there is a natural greenhouse effect where those greenhouse gases and ozone layer, they keep our atmosphere warm, but the right amount of warm. And so what happens when we're in a good balance with the atmosphere is the radiation from the sun comes to the earth, and then the majority of it is bounced off, and then just the right amount is bounced back as heat to the earth. So it bounces around back and forth, but the end result is we have the right amount of heat to keep our atmosphere stable. And what's been happening in recent decades is there's been a human-enhanced, exaggerated greenhouse effect where there are more of those greenhouse gases than there historically have ever been, and they're capturing more of that heat that previously would have escaped back into space. So that's, in a nutshell, the cause of it. And I'll tell you a little, there's other greenhouse gases there, CH4, that's methane, and then there's a few others that you may hear about, but mostly we talk about it in terms of CO2, carbon dioxide, and that's the one that we have very good information on. Here's a trend since over 100 years ago. On the left side, we have the difference in average temperature compared to the baseline of beginning of the past century. And then that line is the increase in the carbon dioxide concentration. So carbon dioxide and the other greenhouse gases, GHGs, we can measure them actually in the atmosphere and have been doing so for decades. And then also we have historic records. So we're able to go back to the 1800s and even millennia before then by looking at ice cores, and there's other methods to see what those levels were in the past. So we have documented that those greenhouse gases are increasing, and the average surface temperature of the Earth has been going up. And a lot of the consequences, I'll touch on these briefly today. You heard about this when you heard the Greenland stories last week. So evidence of climate change includes the global temperature rise, the oceans are warming, the ice sheets are shrinking in the Arctic, the glaciers are retreating. Those are the ice cover on land. There's a decrease in snow cover in places that either have partial or all year snow cover. The sea level is rising. There's a declining Arctic sea ice area. There's extreme weather events, and I think that's probably what we're most familiar with. And the oceans are becoming more acidic. So we're going to focus more on the issues that we're familiar with and that pertain to health, and I'll transition to health issues in a minute here. So resources are important. Drinking water is a precious resource, and in a large portion of Africa, Tanzania and beyond, the glaciers at the top of the famous Mount Kilimanjaro, they provide drinking water for a large population there. And this is an example of the glaciers that have been melting, and that this has been documented in the past 100 years. So the glacier of Mount Kilimanjaro has shrunk by 85% in the past 100 years. And researchers predict that in another decade or two, this highest mountaintop on the whole continent of Africa may lose its snow cover entirely. And climate change in a lot of places will cause a humanitarian catastrophe. These people who live and who depend on this supply of drinking water, they may be the first victims of climate change, because if they're not getting the drinking water they need to survive and to irrigate their crops, then they will need to go somewhere else. And so people fleeing their native traditional lands because they don't have the resources they need anymore, or because it's too hot, or because it's flooded. These are going to be consequences for populations worldwide. So glaciers are one element, and drinking water. And this is a new term for me. You know, we have the South Pole and the North Pole. There's also the glaciers on the Tibetan Plateau are referred to as the third pole. These glaciers on the Himalayan and other mountains feed 7 Asian rivers that serve 40% of the world's population. And the Tibetan Plateau, these glaciers are not as well studied as Mount Kilimanjaro. We have good data. The glaciers in Europe and in North America are well documented, and you've probably seen those before and after photos. We don't have as much information because these areas are, some of them are, researchers are banned from going there because they are religious historic sites, and others just because of the difficulty of accessing them. So I don't think we have as strong information on the Tibetan Plateau, but this is to give you a sense of how many people are potentially being impacted if this resource is depleted. The sea level has been rising, and this is happening for a couple of reasons. One is because the melting ice and the melting glaciers are adding to the amount of water in the world's oceans. And then also, as the seawater is warming, it's just basic physics, it expands. So the sea level is predicted to rise by several feet in this century. And it's not just the rise as a permanent condition, but also it causes a factor when there's storms and high tides. These surges become higher than they would previously be. So areas that are affected not only by being permanently flooded, but then further inland areas can be affected by these flooding events. And here's just, this is the little cute font there. This is taken from a kid's page. I think this was NASA, but you've probably seen a lot of different maps of island nations or coastal parts of the United States or in other continents where there's different predictions, and we don't know which ones, how it's going to go. I've been hearing that the sea level rise is one of those indicators that's going more quickly than researchers had hoped. And so you can see whether you live or people you know live in an area that's potentially going to be suffering from water intrusion issues, permanent flooding or temporary events. So the oceans are an issue. And then there's coming back to how it's climate change and not just a matter of global warming. There's predictions depending on how much CO2 is emitted and how close we get to controlling that process. There's different predictions and scenarios of what the temperature rise will be and what the changes in precipitation will look like. So on the North American continent, here's a couple different modeled scenarios. One is where CO2 releases are kept low, so they're kept to a 550 parts per billion level for this century, and then the high CO2 scenario is on the right. And so the prediction here is, I wonder if I got this reversed, but anyway, regardless of which scenario it is, there will be more precipitation on our continent the further north you go. And so the northern boundary of the US and then up into Canada, areas are getting greater amounts of precipitation. Meanwhile, the south, especially the southwest of the United States and running into areas of Mexico and Central America, are going to have droughts. So it's not any one thing. It's more extreme events, and a consequence of climate change in one area may be completely opposite of what you find in another part of the same country or different continents. Hurricanes, because the oceans are warmer and because the situation is more unstable and more intense events are happening, We've already seen the intensity, frequency, and the length of time of the hurricanes in the North Atlantic are increasing, and also the frequency of the strongest category hurricanes, the category 4 and 5. These have all increased since the 1980s, and this is related to the Gulf of Mexico and to the Atlantic Ocean being warmer than it previously was. And hurricane-associated storm intensity and rainfall rates are projected to increase as the climate continues to warm. So we have both historic information, we're able to track these changes over time, and then also we have international teams working on modeling and predicting different scenarios and what the consequences will be for sea level rise, for intensity of storms, for the change in temperature. So to zoom in a little more on the health impacts. Most of this information is taken from a intergovernmental agency of the United States. So it's a global change research program. And so this program has put together a series of reports that I'm drawing from. And the conclusion is that climate change is a significant threat to our health in a couple of different major ways. One is it changes the severity or how often the health problems happen that are related to extreme climate and weather events. So things that used to happen are happening more often and more severely. And also it creates unprecedented and unanticipated health threats in places where they did not previously happen. And the way that climate change impacts our health is by affecting our food and water sources. It affects the air that we breathe. It affects the weather and extreme weather events and our interaction with the built and natural environment. Okay, so here's a snapshot of some of the major categories of climate impacts on health. So the most obvious is extreme heat. We have areas where there are more frequent and more severe heat events, and the health outcome is health-related death and illness. So this very distinctly affects people's lives. And this is predicted to continue for the next few decades. Even if we get a handle on our emissions, a lot of the changes that have started, they're kind of like a runaway train. We can try to put the brakes on them a little, but even if our emissions are perfect and we do everything right, it's going to take some time for the environment to catch up to those changes. Outdoor air quality, we had talked a few weeks ago about ozone and particulate matter, and high pollen and allergens also are in that category. These can be more severe in a lot of areas. If you have, they're heat related, the formation of ground level ozone is related to heat, and it also contributes to high particle, high PM events in the cold season. So even though we had a relatively mild, it was mild in December and January, we had these events where the atmosphere was still, we didn't have a lot of mixing and storms, and that allowed particulate matter to build up in the atmosphere. So we had a few of those events in the Midwest this winter. So rising temperatures contribute to air pollution, and then wildfires. You remember they had in the year 2020, last year in the spring, in California and Oregon and Washington, there were very severe wildfires, and people, there's the basic safety of getting away from the fire, but there's so many people who weren't necessarily in danger of their homes catching fire, but they were just in the cloud of smoke. So those increasing rates of wildfires are definitely connected to climate change. So moving on, flooding, rising sea level and more frequent or intense extreme precipitation can lead to contaminated water. And also physically people can drown and be injured in these events. They can get gastrointestinal and other illnesses from contaminants in that water. So this is predicted to continue and in the coming decades. Vector-borne infection, you may have heard of Lyme disease. That's something that used to be an issue in fewer areas, but now the territory of where this where the ticks are changing where they live, and the ability to spread that disease is changing. So changes in temperature extremes and seasonal weather patterns are contributing to vector-borne infection. And so specifically to these ticks, is they're able, because the warm weather is coming a little sooner and they have a wider range of area that they can live, there's more people coming in contact with them. So that's causing greater opportunity for Lyme disease. And the last couple categories, water-related infection and food-related infection. So this is related to increases in temperature, increases in flooding and extreme events. So I'll touch on this a little more. So those are that's some pretty wide-ranging categories of effects on people's health. So to say a little more about extreme heat, this was a modeling study. This is looking from the year 2030 up to 2050 and to the end of this century. There's modeling done by this intergovernment panel, and they're predicting the amount of future warming and the resulting deaths in hotter months and the decrease in deaths during the colder months. Overall, and this is because people can die of hypothermia or effects related to the cold if they're not prepared for it. But despite these cold waves and despite the tragedies in Texas, the overall trend is that we're likely to have fewer cold weather related deaths. So the net change over time is a greater increase in heat related deaths. And so the net change is as high as an additional 10,000 deaths per year in the 209 cities that are modeled by this study, as compared to 1990 as a baseline. So Lyme disease that I just mentioned, the territory that's affected, where we have cases reported. So in 2001, the cases that were reported were very concentrated around New Jersey. I don't know my states that well, but the northeastern coastal area, that's where the most Lyme disease cases were reported. And then in our parts, in the Midwest, they were more concentrated in the northwest part of Wisconsin and around the outside of the Twin Cities of Minnesota. And then just not even 15 years later, it's much more widespread. You have a lot more cases reported all around the Chicago area. Notice the big change in Northwest Indiana, Southwest Michigan. So what's happening here is there's more of these ticks, disease spreading ticks, and people are coming in contact with them over a longer period of time. So there's more Lyme cases. And just to wrap up, these are wide-ranging health impacts that are related to all these different consequences of climate change. And who is the most vulnerable to these changes? Children have a lot of vulnerabilities. Their organs and their immunity system are still developing. They depend on adults to protect them. They spend time outdoors more than adults do. And then the toxicological angle on it is that they breathe more air and they drink more water per body weight compared to adults. So if there's a contaminant in the air or in the drinking water, they're consuming it more than an adult is per pound of their physical body. So they are more vulnerable. They have less control over their environment. There's cues and there's something. Adults will recognize a hazard and keep away from it in a way that young kids may not or cannot. So they are more susceptible to air pollution. They are a sensitive population for ozone and fine particles, as we had talked about. They are susceptible to extreme heat, to the different hazards related to flooding and water contamination. So the way this translates into health is they are at greater risk of developing asthma and having allergies. There's neurological disorders that are related to these climate impacts, heat-related illness. they're more at risk for drowning and other injuries. So children are a vulnerable population in our country and worldwide. Older adults are at risk because their immune system is not as strong as when they were younger. They may have a variety of pre-existing conditions related to their age. They may have limited mobility. So this puts them at risk to these extreme weather events, to air pollution, to extreme heat. There have been documented heat waves where older adults, and there's had to be epidemiology done to research and figure out what exactly was the cause. But in Chicago, we had a couple of different historic heat waves and other parts of the country, and it's the older adults that are succumbing to these extreme heat effects. So it's heat-related illness, really, it's the heat itself, and then also it can cause them to have heart events, heart attacks, and premature death related to their heart disease. Communities of color are at risk because of structural racism and the society that they live in. They may have inadequate infrastructure and health disparities. So these are pre-existing risks, which makes these communities more at risk to flooding and to physical damage to their communities. And we didn't get into this too much, but there's this psychological stress and trauma of these events. So these communities that are already at a disadvantage and struggling with disparities have additional stress and difficulty in responding to these crisis events, and also a greater risk of heart and lung complications. And then similarly, low-income communities have fewer resources and abilities to evacuate. People like to, when there's a hurricane coming, people like to blame the people who didn't heed the word and who didn't evacuate. But it makes a difference whether you have the money to put gasoline in your car, to get a hotel room, to go ahead and take the time off work, to go ahead and drive to another state and stay at a hotel motel for a couple of days. That's prohibitively expensive to some people. So limited resources to evacuate and inadequate infrastructure as a vulnerability. And so these communities are more at risk to flooding and to physical damage to their communities. And they may ultimately be displaced if their neighborhoods become permanently destroyed. They may not ever even be able to come back to where they live. This was the case with people who evacuated after Hurricane Katrina and just were never able to come back. So what are the solutions to this? Well, the first step is to study and to understand what's happening, to not just speculate on whether something is related to climate, and to have a better sense of what can be attributed to those changes. So there have been a series of reports by the global community coming together. So there's an intergovernmental panel on climate change, the IPCC. You may have heard of this acronym. And every couple of years, they put out a new report where they assess the trends and they make their predictions. And this is critical in order for individual countries and for the world working together to come up with reasonable, achievable goals to tackle this issue. So what they've reported so far is that they estimate that human activities have caused about 1 Celsius degree increase in the global temperature above the pre-industrial levels. Global warming is likely to reach 1.5 degrees Celsius between 2030 and 2052 if it continues to increase at the current rate. So the targets and the goals are to limit that climate change to 2 degrees, but to try to keep it as close to 1.5, which seems inevitable, to keep it as close to that level as possible. Warming from human-caused emissions from the pre-industrial period to the present will persist for centuries to millennia, and they will continue to cause further long-term changes. So I alluded to before that a lot of these changes, it's already started. The oceans are going to continue rising. the changes at the Arctic can't just be stopped. It's going to be a long process for them to level off. And these IPCC reports have a lot of modeling and predictions. Here's an example. This is a chart of their observed global temperature change and modeled responses to forcings. Well, that's another issue, but they're predicting. This is on the y-axis. This is the predicted temperature change. So under different scenarios of fast reductions in CO2 versus no reductions of CO2 at the upper end, these are the different possible changes to the temperature between now and the end of the century. So, I mean, they can make recommendations on what changes we should make, how much we should limit our emissions, but not all countries have the political will to make these changes. I'm not naming names. So the modelers need to take into consideration what's the worst case scenario, what's the best case scenario, and everything in between. So the Paris Agreement is a legally binding international treaty on climate change. It was adopted by 196 countries at this initial meeting, and it was you may have heard that the United States was in it and then we're out of it. Well, as of, I think it's just a few days ago, we're back in it. So we're back on the good side of these international agreements. And yeah, the goal is to limit global warming to well below 2 degrees, preferably to keep it below 1.5 degrees Celsius compared to pre-industrial levels. And to reach this long-term goal, countries are working together to reach, to try to get to that peak level of greenhouse gas emissions and then start moving down as soon as we can. And then to have a climate neutral world by mid-century. So in the meantime, how do we respond? One, our response to climate change, first is it's important to mitigate it, to reduce climate change. And this involves both reducing the emissions, the flow of those greenhouse gases into the atmosphere, either by reducing the sources of the gases, or another approach is by enhancing the sinks or the places where those gases can accumulate and be stored for a period of time. So this is where the technology comes in. I don't exactly know how putting it in the ocean works, but there's different, you may hear about carbon sequestration. So there's different ways to capture carbon, to just like pull it from the atmosphere. We kind of refer to carbon dioxide and carbon as the same thing, because the point is carbon is like shorthand for carbon dioxide. So we want to capture it from the atmosphere. And one way to do that is planting more trees, because the trees consume carbon dioxide, and so that's a way to keep it locked up. And then the other thing is adaptation, and this involves adjusting to actual or expected future climate. Our goal is to reduce our vulnerability to the harmful effects of climate change. So sea level encroachment, more intense weather events, food insecurity. In the US, we have so many of those coastal communities where it's interesting to see the dichotomy, where for political reasons, people may feel like, elected officials may feel like they can't talk about climate change or global warming because it seems like it's one party versus the other. And so they don't want to admit or acknowledge that climate change is happening, and yet their coastal community has got more severe flooding than it ever did in its history. And so these cities and regions are planning for it, to protect their downtown, to make them better able to respond to these events, so to plan for it and to be able to respond. And also there is the possibility to take advantage of some of the benefits. So we will do what we can to prevent these changes. But if there are some areas where we have a longer growing season or the ability to grow a crop that we couldn't previously grow, then there are some communities and countries that can take advantage of that. So plan A is to limit greenhouse gas emissions. And then there's a lot of high-tech ideas for plan B. which is, this graphic summarizes a lot, but on the upper right, the direct capture of CO2 in the atmosphere, there's different technologies for that. The opposite of deforestation is afforestation. So, so I don't know how realistic this is because we do need cropland. So, do we devote some cropland to planting trees instead? Maybe. A lot of the reason behind meatless Mondays and vegetarianism in general and veganism is because people have recognized that if you're raising cattle, to produce the same amount of protein as a plant-based protein, it takes a lot more land. So if we switch from a land-consuming red meat component of our diet and allow that land to be reforested, then that's a way to contribute to protecting our climate. Some of the more fanciful approaches include giant mirrors in space to reflect some portion of those sun rays, or injecting tiny reflective particles into the clouds to reflect some of these rays. Because we're capturing and keeping close to the earth too many of these rays, let's just have fewer of them coming in. So I don't know which of any of these are actually proving to be realistic. I think our plan A is the better one to focus on. And it's not, we do hear, these are these national level and state and city level plans that need to be implemented to reduce our emissions. But then there's also what we could do as individuals. So everyone can do what they can to reduce what's called their carbon footprint. And this is the amount of CO2 released into the atmosphere because of your own personal energy needs. So the way to reduce your carbon footprint includes unplugging electronic devices, because any power that you're using that's coming from a power plant, which is burning fossil fuels or some other way contributing to CO2 emissions. So keep your heat on to a lower temperature in the winter, keep your air conditioning low when it's hot, and bundle up. I wear 2 or 3 sweaters around the house. I've got a blanket in my lap right now. I don't need to heat up the whole house just because I got up early to talk to you guys today. Walk or ride your bike. There's a lot of ways to commute where we're not burning as much CO2 into the environment. So that's what we can do ourselves. And hopefully this will motivate you to make some changes in your own life and to do what we can to influence the powers that be to make big changes, because we can't do it ourselves. We need to work as a society and as a global team. So I don't know if I've gotten us.
Right.
Do we have any time for questions, or you can email me if you have any questions. You can follow me on Twitter at Mochinka.
Okay, so let's give Dr. Caudill a round of applause. We could take one question maybe before you guys take off here. Anybody has a question? I have one question among many. I'll just ask one. So can you give us some more examples of infectious diseases that were once like only in the tropics that are now spreading to mostly like northern areas?
I believe the area affected by malaria has been expanding. Yeah, that's definitely related to, similar to the ticks.
Okay.
They're and West Nile virus also, which is spread by mosquitoes. Yeah, so there's, and you're exactly right. It's areas where it used to be restricted to the more tropical climates, but as the warm season is longer and the area that these creatures can live is bigger. Yeah, you know, I have a longer lecture for the graduate students coming up.
I think,
and
I think isn't Zika virus also another one? Zika virus is also moving geographically.
Oh, I kind of forgot about that one. There's a couple of different categories. So there's waterborne illnesses.
Mm-hmm.
So it's algae. There's different types of algae that can cause GI gastrointestinal effects.
Mm-hmm.
They can contribute to asthma because the algae gets into the air.
Mm-hmm.
So there's different algae and bacteria. So that's in the water. So it's mostly the stuff in water contamination. That's mostly if you accidentally ingest it, it causes a gastrointestinal effect. But then there's also some different microbes that if you have an open sore on your skin, so if there's reasons, the Centers for Disease Control, they will give you recommendations on if you have flooding in your area, here's safe ways to reoccupy your home and clean up your home. And part of it is don't have direct contact. If there could be sewage in your flood water, then those bacteria, you could accidentally ingest them, you could get it on an open sore, and some of these can cause severe infection if they get into your skin. So waterborne illness, and then there's increased risk of foodborne illness.
So I'll have to let my students go. If anybody else online wants to continue, we could continue for a few minutes online. But again, thank you very much. And I'm pretty sure some of our kids might be interested in this topic and might want to communicate further with you.
I'd be happy to.
Mm-hmm.
The homework is 39 to 77.
Thanks, everyone.
Is the what?
Is the homework 39 to 77?
I don't know off the top. I could send me an email and I'll send it to you. Okay. Okay. All right. Well, we can go on for quite a bit on this topic, but I'll let you go. And thank you very much again for giving us 2 lectures in our series. We will put these all online so that everybody could, listen to them at their own pace, think about them, reflect on them, and make the necessary changes. Thank you again.
Okay. Thanks, everyone.
Okay, take care. Bye-bye.
Bye-bye.